Hello and welcome to another tutorial. We're looking at the operators in Java, and we started with the simplest operator, which was the assignment operator. To refresh your memory, the assignment operator is 1 equal sign, and that means whatever is on the right hand side of this operator will get evaluated first, and then the result of that will be assigned to the left hand side. Obviously, if you have some sort of expression or call to a function or method, whatever, the return type of that method must be able to match or kind of be compatible with the type of the left hand side, either direct match or some sort of implicit conversion. Otherwise it's not going to work. And we saw that the main differences between the assignment operator in Java and C++, how to overload them. The next one, obviously, so assignment operator is pretty much the most widely used operator, and after that we have the math operator, right? Arithmetic operators: addition, subtraction, multiplication, division, and remainder. And the remainder is not as widely used as the first four operators, because remainder only works for integer division. When you're doing things like scientific computing, you always deal with floats and double, right? Floating point numbers. So remainder doesn't really you don't really use it that much. However, if you're doing like designing a memory buffer, for example, and you want it to be a circular buffer. A circular buffer means you have a limited size, let's say 2 megabyte, and if you run out of space, you roll back and circulate back to the beginning and start to fill the beginning of the buffer. That's when you have if you back your circular buffer, for example, with a fixed size array, which is the most obvious choice, because the size is defined, it's fixed and predefined, then you can use remainder to circulate back in the array, because when you have, for example, if you know the size, and then you can divide the index, or basically use the index modulus that size to to circulate back. So let's try to create a new class, let's say a circular buffer, for example, right? And then what we want to do is, I want to just show you a quick example of, let's say we have an int array, right? Buffer is new int. Let's say we're going to go with 1000 elements, 124, right? And then so each int is 4 bytes, and then multiply by 1k. 1k means 1024, right? 1k, k is 2 to the power of 10, for example. And then we get with 4 kilobyte. So this is like 4 kilobyte. So this is 4 kilobyte of buffer, for example. And then what I want to basically circulate back into the array. So the way we do it with the circular indexing of an array means you get the index of the element, you use the remainder operator with the size, right? So maybe it's good to also have the int size is 124. And as you recall, we said that in our discussion with the arrays in Java is, regardless of the type of the elements of the array, the index into the array is always int. That's just the limitation that the Java designers decided to go with. And in some way it makes sense, because integer is 2 billion elements, and even if you go with byte array, which is the smallest element type in Java, 2 billion elements means you talking about 2 terabyte of array. Just one single array occupying 2 terabyte of memory. That's almost never happens in reality. That's why it's okay to have int for indexing into arrays. Now in C++, they decided to go with size t. So in C++, indexing into arrays is basically size t, and it depends on your platform, your computer, your CPU, your operating system, and usually this maps to the largest integer your platform supports, right? For example, the largest integer that Java supports is long, which is 64-bit. In C++, you might have long, which is 128-bit, etc., right? Even 8-byte or 16-byte. Usually size t maps in 64-bit platforms, Intel CPUs, for example, on my operating system and platform, it maps size maps to a 64-bit integers, whereas Java never allows that. In Java, indexing into arrays is always 32-bit integers. Okay. Now we say so we're going to say that for int I equals 0, I less than let's say twice the size, right? -10, and I plus plus or plus plus I, both are valid. And then we're going to say that buffer at index I equals I. All right. Now if I run this, I'm going to get the array index out of bound exception, because obviously we know that Java at runtime checks to make sure that you're not accessing an index outside the range. But then the question is, let's say I want to start from index 0 and start filling up the array, but then if I get to the maximum size, I want to circulate back to index 0. So the goal is to circulate back to index 0 if we fill up the array. Remember, array is a terminology we usually use in Java, but in the low-level languages, especially in C or C++, especially in C, the terminology is buffer, memory buffer, or memory buffer. Buffer just means array, a low-level array or a built-in array. That's remember that in C and C++, just like Java, arrays are a built-in type, built-in arrays, right? So I'm just saying that in case you are reading something in the context of C programming language, which is still very similar to Java in the syntax, and then you come across the terminology buffer or memory buffer, all it means that it's just a piece of memory, right? It's a built-in low-level array type. Now we know that in C++ they introduce a more type-safe array, right? Template, it's a template, and then you say that std, for example, array, and it's a template, the type, and then the size. So, and then this behaves exactly or pretty much like the built-in arrays in Java, because you give it at the compile time, you have to specify the type and the size, and then it also has, in Java you have the dot length that you can call on the array. Here you just call the dot size or something, right? So we have a buffer, which is a fixed size array in the memory, and we want to start filling it up. And if we get to the maximum capacity or the last element, we want to circulate back. And the way you do it, you use the modulus operator, size, right? Or we can, in this case, we can say buffer.length, because arrays in Java or memory buffers in Java keep track of the length, right? But here I already know the size is exactly this variable, so I keep track of it. Now this is not going to fail, right? So if I do, everything works fine, because now using the remainder operator, we are circulating back. And to show you that, I can actually also print this I modulus size equals, and then plus I modulus size, right? And you will see that so 124, so we are filling up the array, right, from 0, 800, 900, and 1023. This is the maximum size, right? We know that if the length is 1024, it means we start from index 0 to index, the last index is size -1. So I'm gonna write it down here. Last index is size or length of the array -1, 123, and after that we are circulating back to index 0. This is the meaning of a circular buffer. So if your buffer fills up, you go back to the beginning and start filling up from that part, right? That's the meaning. And then we go all the way to 2 size -10. In this case is 1013, right? Last index is 1023, -10 is 1020. So this is the meaning of circular arrays, circular buffers, and this is pretty much the most important use case of a remainder operator. Whenever you have a buffer or I don't know, a list or something, some sort of data structure that has a fixed size and you want to circulate back to the beginning. Usually this works for data structures that support indexing into them, and have some sort of order, for example a linked list or a internal or a built-in array type. And again, the most use case is for the built-in array types or in C buffers, right? So I hope you understand this remainder operator very well. The rest of the operators are usually used with floating point operations. So the Java programming language provides operators that perform addition, subtraction, multiplication, and division. There is a good chance you will recognize them by their counterparts in basic mathematics. And again, the way they are designed in terms of precedence is pretty much the same as you would expect in a normal math. Otherwise, it wouldn't make any sense, right? You want to use these operators in the same way you use them in real life when you're doing math, which means multiplication, division, and modulus, they have the highest precedence, and then plus and minus, they have the lower precedence. And then if you have, for example, operators that have the same precedence in the same expression, then the entire expression gets evaluated from left to right. That's just because the syntax or the source code is written in English language, and English is from left to right, right? That's how this is designed. The only symbol that might look new to you is modulus, which divides one operand by another, and both have to be integer and returns the remainder. And again, this only works for integers, right? So if I say, for example, I mean, first of all, these operators obviously work for both literals and variables, right? I can say 10 modulus size. This works, and obviously this is a binary operator, so you have to assign the return type to something, var x1, right? So this works. You can have literals on both sides. That still works. You can have a variable on one side and then literal on the other. This works. You can have basically literal or variables on both sides. So these are binary operators, and you can mix literals with variables, right? Name the variables and the actual literals, and that works. And modulus, you see here I'm using a floating point, and the question is what happens when I do or divide an integer by a floating point. That's very interesting. So let's look at it. We get 4 float. What this means is that 124. So what happens here is that 124 divided by 10, right? And what this does, the way this works, I believe it converts the non-integer types to integers. So this gets translated 124 divided by 10 integer, and that results in 4. The remainder is 4, right? Remainder. So it's interesting that Java allows this implicit conversion. And let's test this. So if instead of 10, I say 10.1 and run this, we get 3.9. So let's do a sysout 124 double divided 10.1 and then run this again. Actually, what the question is, so this is the remainder, and if we say var x2 is basically 124, we convert it to float minus this one, and then x2, and we get 9. So obviously, if the way this works, remainder, you have to divide and then get the quotient multiplied by the quotient again minus the original one to get the remainder. So I'm actually not sure how this remainder operator works for non-integer types. That's very interesting, and you can Google it to see how this works. My intuition was that it's going to convert the non-integers to integer and then do the integer division, but apparently that's not what's happening, right? Because if I divide by 10.1, I'm getting 3.9. Which is very interesting. So that's the remainder. So Yes, so this is very interesting that this remainder modulus supports the non-integer types as well in Java. All right, so addition, subtraction, multiplication, division, remainder. The following program arithmetic demo tests the arithmetic operators. Let's go full screen here, and then int result 1 plus 2, and again the right hand side gets evaluated first using the, and then the assignment operator assigns the right to the left. So result is obviously 3, and then result minus 1. This is subtraction, multiplication, division, and then we said that these binary operators allow you can mix the literals with variables and modulus 7. And again, we pretty much always use modulus in the context of integers, 2 integers, but apparently this modulus in Java also supports floating points, so it doesn't have any restriction and you don't get a compiler error. You can also combine arithmetic operators with the simple assignment operator and to create compound assignment. For example, plus equal, this means basically plus equals means whatever is on the left hand side gets its value, add it to the whatever is on the right hand side, and assign the return value to the left hand side. And this is pretty much equivalent to x equals x plus 1, right? These are basically equivalent, the same exact bytecode. Both increment the value of x by 1. So I don't believe there is a different bytecode that does this compound arithmetic or compound assignment. These two eventually translate to the same number of bytecodes, probably 2 bytecodes. The plus operator can also be used to concatenate or join 2 strings, and this is the only place, again I'm going to repeat, this is the only place where the plus operator is overloaded in Java, and that's for strings and string literals. Why? Because those are final, you cannot extend them to create your own custom type, so that JVM always knows how to understand the plus operation between 2 final classes, 2 string classes, because they're final and then their behavior never changes. The user cannot actually change their behavior. That's why they decided to overload this plus operator. So if you have 2 strings or string literals, remember binary, you can directly write the string literal on either side, or you can assign them to variables and then concatenate the variables of type string. And this plus also works for any non-integer type or non-string type. For example, I can say a string first is hello exclamation mark, and then sys out first plus 25, right? This still works. It just creates we have already looked at the bytecode, and we already know that in recent version of Java the compiler translates these 2 lines into creating a string buffer or a string builder, and then it calls the append method that takes an integer. Remember the append method of a string builder is overloaded for all types of built-in types. So if you look at the bytecode, we definitely will see a let's open it with the class file viewer and put this side by side, and then if I go down, as you can see, we are creating a static, or basically a string builder, right? We're creating a string builder, and then we load the 5. This is the first, right? A load means load a reference, an object reference, or basically something that points to an object in the Java heap, and index 5 of the stack. So we are loading this, right? The variable first, and then invoke a static value of, and then so it's not calling the constructor, it's calling the value of, and then passing some sort of object, and then returns a string, and that object is basically it creates, so you get the string literal, and then from this we call the string value of method to actually create a string and put it here in this first, and then invoke a special. We invoke the constructor of the string builder, we pass this string literal to it, right? And then we push 25, which is an integer literal, to the stack, and then we already created a string builder, and then we call the append method that takes an integer for the string builder, and then that creates a string builder that holds the value of first appended to 25, and then we call the toString method to convert it to a string. Remember, whenever you pass an object to the println method, then it automatically calls the toString method, and then we get the string and print it by calling the println, right? So this is complicated, but remember that string concatenation in the recent versions of Java is always done by a string builder, and the append method in a string builder is always overloaded for all built-in types, right? And so these are the mathematical operators, and then we have also the compound operators that also works for strings, I believe. So we can say a string second is first, or a string second. Obviously you cannot say plus equal first, right? Because second is not initialized. So let's see if we can initialize it. World dot and then second plus equals first. This works, right? And sys out second. Now what happens here? The problem here is that let's see, and second plus equal first is equivalent to saying that second is second plus first. So world dot and hello, and then assign it back to second. It doesn't mean, remember, strings are final. Strings are final, so you cannot mutate them. You cannot mutate the content of a string object, but what you can do, you can point this reference to another string. So second plus first, this plus operator is overloaded for strings. It returns a new string, and now the second is pointing to the new string, which means the original string here is lost. It's now eligible for garbage collection. That's it. That's the meaning here. We didn't mutate the actual state of the second. We didn't mutate the buffer, the character buffer that it holds. We just reassigned this reference or pointer to another string because a new string was created. The return value of this plus operator is a new string, and now we're pointing the string to the new one. This works. Note that the compound assignment doesn't work when you are initializing. Compound assignments don't work when you are initializing. Basically, declaration, you are declaring plus initializing. What I mean by that, you cannot say int x plus equal 5. This doesn't work because the variables don't get a default value in Java, right? So you cannot do this. You have to first initialize it to some value and then say x integer in this case, and then x plus equal whatever 5. This works because this translates into x equals x plus 5, and x has to be initialized first so that you can write, remember, assignment operator, the right hand side has to be evaluated first, and the result of the evaluation is the return type of the assignment. So you evaluate and assign the return type or the result back to the x itself. With strings, remember, in this case we are actually modifying the content of x. X was a pointer or a reference to a integer variable that holds 0. Now it holds 5, the same memory address. But for strings it's different. When we say a string 1 plus a string 2, or basically second plus equal first, it actually, this plus operator returns a new string which is not at the same memory location as the whatever the original second string was, right? And now we are pointing this second reference or second, this is a pointer or reference, to the new memory location. However, in this case we're not pointing x to a new memory location. We are at the same memory location. We are just modifying the content. So I want to really understand the difference between this plus operator that works for the string objects in Java, and then the plus operator that works for the like primitive types, other types. These are two different things. Strings are unmodifiable. We cannot modify them. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.